stress factors on the airman performance. So these stress factors are the key factors for the airmen that is impacting the performance, and our job how we can protect the performance degradation. So that is a big gap. And when we try to say the stress factors, they are like not only limited to what we described here, hypoxia, stress, fatigue, vigilance, directed energy. So now there are even in the operational environment, the airman is exposing to a lot of non-invasive radiation. So, like in the cockpit, not only in the cockpit, even in the different environment, there is so much, electronics. There are a lot of things coming up. There are a lot of synergetic effects associated with that. And that's one thing. The other thing, there is a lot of material effects. We cannot ignore that the Air Force is really manufacturing, synthesizing some of the modern material for the weapon system, and our airmen during the manufacturing, during applying in the acquisition environment. So in every step, right from the laboratory and in the practice and the training and the actual application in the acquisition environment. So those are the materials, those are the maybe chemicals we cannot ignore, and they are the key stress factors that's impacting. Not necessarily the acute, but there might be a long-term implication. So in order to identify, there's several components. One is precisely characterizing those stress factors. And if we can real-time monitor those stress factors, that becomes the sensors. That's the Nancy's ally. So we can help her. Hey, how can we develop some of those sensors for the airmen? It is always catching up those stress factors. Hey, these are the quantity, these are the quality. So that's one way. But once we identify what are the key physiological events, and that is where we as a branch, we have a great capability with the young workforce. For example, Laura has really outstanding experience for developing complex in vitro models that can simulate human physiology. And we have Tyler, who can come up with a good models, how he can engineer, So engineering these in vitro models to simulate human physiology. So that's really, again, you can go from identifying the stress factors, looking some of those impact long-term or short-term, and how can we extrapolate to the actual human, and there are a lot of things that we need to develop. And those are the key technologies, and identifying the key mechanism. So we need to come up with the novel mechanistic approaches, emerging technologies. So one of the technology, I would come up with the gene editing technology. So there are so many things that they are coming up now. They are already using for medical application, but how can we use for our mechanistic approach? And maybe there are other applications. So now they are even talking about the brain on chip, like putting in the aircraft that can work as a human being. So they're talking about how we can improve, because not just with the cells, they're developing some kind of artificial cell models that serve as a brain on chip. So there are so many areas we can develop to address the gaps, which is again the airman augmentation, protecting the performance degradation.
Thank you.